Hello students, today we'll discuss the science section of the December 2020 ACT Form D03. So let's begin. Passage 1. Scientists conducted a study to examine the caching, storing food and feeding behaviors of gray squirrels. Prior to the study, acorns were collected from a park and sorted into types. First, according to the species of tree they grew on, red oak, pin oak, or white oak. And then according to whether the acorn was undamaged, infested, that is contained insect larvae, or shelled, that is the shell was removed. Each acorn was stored as 2 degrees centigrade until the day it was to be used. Okay, the study was conducted over 75 consecutive autumn days, beginning at the same time each morning. 225 acorns were placed one at a time at a given location in the park where the acorns had been collected. Each of the 9 acorn types was presented an equal number of times. And the order in which the acorns were presented was random. All the acorns were picked up by squirrels within a minute. Table 1 shows for each acorn type the percent of acorns that were cached, eaten, or rejected, that is dropped after being picked up by the squirrels. So there was 3 kinds of acorns: red oak, pin oak, and white oak. And within those, there were 3: undamaged, infested, and shelled. And these are the percentages which are given. Okay, in addition, for each red oak acorn that was not rejected, the average distance, including both horizontal and vertical, the squirrel traveled before caching or eating the acorn was determined. Okay, the study was most likely designed to answer which of the following questions. Does the presence of insect larvae in acorns increase the amount of protein consumed by the squirrels? Are squirrels more likely to reject acorns that are infested or acorns that are shelled? Okay, does the percent of acorns catched by squirrels vary from season to season? And are squirrels more likely to travel a greater distance during the morning or during the afternoon? Okay, so clearly the answer for this question is B, because if you look at the experiment, it is looking at the kind of acorns the squirrels are likely to accept or reject, right? Option A, which talks about protein consumption, is not something the passage discusses. The variety of variation is season is not something that the passage discusses either, because everything happened in autumn. And option D, that is also something that is not discussed. It is the experiment does not distinguish between morning or afternoon. So B is the right answer for the first question. Which of the following factors was held constant during the study? Percent of acorns that were cached, time of day scientists began placing acorns at the park, order in which the acorn types were presented, and distance a squirrel traveled before eating acorns. So the factor that was kept constant was the order. This is given right here, that each of the 9 acorn types was presented an equal number of times, and the order in which the acorns were presented was random. Oh, that was random, right? So it was not H. It's because constant would mean that that's not correct. Percent of, that's not correct. Distance is different. Time of day scientists began placing. I think that was constant. Beginning at the same time each morning, right? So that is G. Okay. Which of the following statements about pin oak acorns is consistent with the results of the study? Pin oak, right? So that's like this one, pin oak. So I'm just going to put it like this. Shelled pin oak acorns were eaten more frequently than infested pink oak acorns. So eaten, right? So shelled more than infested. That's not correct, because shelled is 64 and infested is 68. So A is out. Shelled pin oak acorns were rejected less frequently than undamaged. No, that's not correct. 16 and 12. So shelled were rejected more frequently. Undamaged pin oak acorns and infested pin oak acorns were cached 24. Undamaged and infested were cached 24%. That is correct. Undamaged This is cached, yeah. Undamaged pin oak were cached 64. Yeah, so that's not correct because the second column is eaten. So it's C. Okay, according to table 2, before eating shelled red oak acorns, the squirrels traveled an average distance of, before eating shelled red oak, 15 meters, right? Eating, it is 15, J. Which of the following statements comparing the distances squirrels traveled before eating infested acorns to the distances they traveled before caching infested acorns is supported by the results? On average, the distance traveled before. So the difference traveled before caching is on average less than the distance traveled before eating, right? The distance traveled before eating was farther than the distance traveled before caching for infested. So A seems right. Caching was farther. That is not correct. This is which acorns? It is red oak, right? So white oak is not even in consideration. So C and D are out. So eating was farther than caching, A. Okay, assume that the more perishable, likely to decay a given type of acorn, the more likely a squirrel is to eat that acorn rather than cache it. So it is likely to eat it rather than cache it if it's perishable. Consider the results in table 1 for the shelled red oak, infested pin oak, and undamaged white oak. Okay, so I'm just going to mark those. They want us to look at shelled red oak, this one. They want us to look at infested pin oak, which is this one, and they want us to look at undamaged white oak. So these ones, right? The third, second, and first. Okay. Based on the results, what is the order of these three acorn types from most perishable to least perishable? Okay. So if it's more perishable, it is likely to eat it rather than cache it, right? Right. So if it is, so 60, 64, and 76, right? So I would say, no, 60, 68 and 88, right? These numbers. I'm looking at eating and caching numbers. So that's just 60, 68, and 88. So it is, so the most perishable is white oak, then pin oak, and then red oak, right? Because red oak, the caching is the highest percentage. So let's see if we can choose that. So most perishable is undamaged white oak, then infested pin oak, and then shelled red oak. So it's J. Okay. This is J. Of the 1875 undamaged pin oak acorns tested in the study, the number of those acorns that were cached by squirrels was closest to which of the following? Okay. So how many? There was 1875. Right. Pin oak acorns. So pin oak is this one, 1875. This number of that were cached by squirrels. So they were, 1 second, undamaged pin oak. Okay, undamaged pin oak, 24. So 24% of those were undamaged pin oak cached. So 24% of 1875, we'll just plug that in the calculator. 0.24 into 1875, 450, right? I'm just going to make sure that I didn't undamaged pin oak acorns, right? Cached by squirrels, undamaged 24. It is 24, right? So that becomes point, yeah, it's 450. That's not an answer, but I'm going to go with B, which is the closest. Hmm. 225 acorns were placed. Okay. Right. 225 into, yeah, okay. Let's go to the next one, passage 2. In the periodic table, a column of elements is called a group. For each of 5 elements in group 2A and for each of 5 elements In group 3A, table 1 gives the atomic mass, average mass of one atom in atomic mass units, AMU, and 3 other properties at a temperature of 298 Kelvin. Okay, density, specific heat, amount of heat required to raise the temperature of 1 gram of substance by 1 Kelvin, and thermal conductivity, ability to conduct heat. The greater the thermal conductivity, the more effectively the substance conducts heat. Figure 1 shows for aluminum and for magnesium how the thermal conductivity varies between 1 Kelvin and 100 Kelvin. Okay. Based on table 1, among the group 2A elements, as atomic mass increases, the specific heat. 2A, right? Group 2A elements. Yeah. As atomic mass increases, the specific heat is decreasing, right? It's going from 1.83 to, so that's specific heat decreases only, G. Okay, according to table 1, at 298 Kelvin, the specific heat of indium is closest to the specific heat of which of the following elements? Okay, at 298 Kelvin for indium, it is closest to which one? Okay, so indium is 0.233. 0.233, I think would be closest to barium, right? That's the closest, yeah. So barium it is, right? A. Based on the definition of thermal conductivity and on the strontium or thallium conduct heat more effectively at 298 Kelvin. So strontium or thallium. Strontium is 35 and thallium is 46. So it will be thallium, right? Thallium, the thermal conductivity of thallium is greater than that of strontium. So H. Okay. Neither table 1 nor figure 1 give the thermal conductivity of magnesium at which of the following temperatures? Which of the following temperatures? So for magnesium, it is from 0 to 100, and 298 we already have. So that's 200 Kelvin. So C. Okay. Based on figure 1, at which of the following temperatures is the thermal conductivity of aluminum closest to the thermal conductivity of magnesium? At which temperature are they closest? So that is, I think, at any temperature after, I would say 70 Kelvin, like 80. Yeah? So J. What is the meaning of the value for the density of indium given in table 1? Density of indium given in table 1, 7.31. So 7.31, so 1 centimeter cube is 7.31 grams. Each centimeter cube of indium has a mass of 7.31 grams, right? Mass by volume. So that's A. Okay. Okay, let's go to passage 3. When viewed from above, the path of a launched object is expected to be a straight line. However, because Earth rotates, the Coriolis effect causes the object to be deflected either to the right of the expected path in the northern hemisphere or to the left of the expected path in the southern hemisphere. Okay, the magnitude of deflection is the distance that serves as a measure of the Coriolis effect. The MOD is the same when measured at the same latitude, for example, 30 degrees in either hemisphere. Now, students conducted 3 experiments to study the Coriolis effect. First experiment, they performed 5 trials, each at different latitude. In each trial, they launched a ball due east at a speed of 25 meters per second over a distance of 100 meters, and they measured the ball's MOD, the magnitude of deflection in centimeters. The second experiment, students performed 5 trials, each at the same altitude, 45 degree north. And in each trial, they launched the ball due east at a different speed. So this time the speed was changed, and then they measured the MOD, which is magnitude of deflection, right? And in the third experiment, the students performed 5 trials, each at a different latitude. In each trial, they repeatedly launched 2 identical discs, each 4 centimeters in diameter, directly towards one another at identical speeds across a 200-meter long frictionless horizontal plane. Right. The speed was adjusted for each launch until the students had determined the minimum launch speed required for the discs to just avoid colliding. Minimum speed required for them to just avoid colliding. Okay, and this is at different latitudes. Okay, suppose that in experiment 2, the students had launched the ball at a speed of 33 meters per second. The ball's MOT would most likely have been. So we know that as the speed increases, the MOD decreases. So if the speed is between 30 and 35, the MOD would be between 1.47 and 1.72. So that's just H. Okay, according to the results of experiment 1, as latitude increased, the MOD due to Coriolis effect. So as the latitude increased, the MOD also increased. So B, right? Okay, based on the results of experiment 3, which of the following graph best shows the relationship between latitude and minimum speed required to avoid a collision? Okay, so as the latitude is increasing, the minimum speed required to avoid a collision is also increasing. So we'll go with option J because that's showing a continuous increase. Right. The students made certain to use the same ball in both experiment 1 and 2. The students most likely did this to ensure that the ball's MOD would be unaffected by variations in object shape or mass, unaffected by variations in launch speed or latitude, the same and different. So the reason they used the same ball was because they wanted to capture only what they wanted to capture, which is the variations in launch speed and latitude, right? They didn't want the ball's shape or mass to affect the results, so it will be A. Okay, based on the results of experiment 2, by how many millimeters did the ball's MOD decrease when the launch speed was increased from 15 to 20? So it went from centimeters, right? So I'll do 34.4 milliliters, millimeters. I'll just plug this in. 34.4 minus 25.8. So that's 8.6. That's exactly J. Okay. Suppose that in experiment 1, a trial had been performed in which a ball had been launched at a speed of 25 meters per second at 45 degrees south latitude. Okay, so you're doing 25, this is north, but now they're doing 45 degrees south. This trial would most likely have resulted in the ball deflected to the, so it is, the MOD is the same. The left of the expected path in the southern hemispheres, right? So it would be the left of its expected path, but the MOD would be the same by 2.06. So left of its expected path with an MOD of, so it's C. Okay. Which of the following statements best summarizes the procedures of experiment 3? Experiment 3, right? This is when they change the latitude of the discs to get the minimum speed at which they want to collide. The students repeatedly adjusted the disk's launch speed until the resulting MOD for each disk was larger. Repeatedly adjusted the latitude at which the disk were until the resulting MOD. Repeatedly adjust the disk's launch speed until each disk was slightly larger than 200. Why are we dealing with that? Across 200-meter frictionless, right? So if you're doing that and you don't want them to, so the MOD has to be higher than, why would it be higher than 200 centimeter? The MOD would need to be higher than, 1 second. Yeah, the diameter is 4 centimeters. So the MOD needs to be higher than 2 centimeters because then obviously they will not collide, right? Yeah. So that's 2 centimeters and they adjusted the latitude, right? So it's G. Yeah. Okay. Passage 4. In human blood, calcium concentration is regulated by vitamin D3. First, vitamin D3 is converted to calcidiol in the liver. An elevated concentration of CD inhibits further conversion of vitamin D3. Next, CD is converted to calcitriol in the kidneys in a reaction that requires parathyroid hormone. An elevated concentration of CD increases calcium concentration, which in turn inhibits further release of PTH. Okay, so vitamin D3 converts to calcidiol in the liver and in the kidney with the assistance of PTH. It converts into calcidiol converts into calcitriol. Okay, now figures 2 and 3 represent show how dietary consumption of vitamin D3 affects relative blood CD calcidiol concentrations and how blood calcium concentration affects relative blood CT calcitriol concentration. Okay. According to figure 2, if an individual increased dietary consumption of vitamin D3 from 1 times the normal, 1 represents the normal concentration relative blood. Okay, so it is 1 time the normal to 2 times the normal. Okay. What the individual's relative blood CD concentration increase. So this is 1 from 1 time to 2 times the normal. I'm trying to figure out what the graph means. If an individual increased dietary consumption of vitamin D3 from 1 times the normal. Okay. Okay, 1 times the normal to 2 times the normal, then that doesn't change, right? The individual relative blood CD concentration does not change because the relative blood CD concentration would remain the same. It will be B. Okay. Then according to figure 3, the relative blood CD concentration is between 5 times normal and 6 times normal within which of the following calcium ranges. So this is 5 and 6 times normal between 0 and 8.9 point something rather, right? Yeah, so 8 and 9. 8 and 9 for sure. Yeah, between 8 and 9 for sure. So F. Okay. According to figure 1, what activates the conversion of CD to CT? Conversion of CD to CT is PTH, right? D. Okay, according to figure 3, when an individual's blood CT concentration is at a normal value, the individual's blood Ca2 plus concentration is closest to the following. So when it is normal, so 1 is the normal blood, so this is closest to about 9.6 or 7, something like that. 9.5, so H. Yeah. According to figure 2, the greatest variation in relative blood CD concentration occurs when the dietary consumption of vitamin D3 is within which of the following ranges. The greatest variation occurs, it has to be between like, I don't know, like, yeah, it's almost 0 to 0.25, 0.4, 0 to 0.25, I would say, right? To 0.25, yeah, 0 to 0.25 for sure. So it's A. Yeah. Okay. According to the given information, the inhibition of the conversion of vitamin D3 to CD is caused by inhibition of vitamin D3 to CD inhibition is caused by a higher amount of calcidiol, right? An elevated concentration of calcidiol, which is G. Okay. Right. Passage 4. The Atwood machine shown in figure 1 was used as part of 2 studies on objects moving with constant acceleration. Study 1, in each of the 10 trials, the following procedure was performed. A string was passed over to pulleys. The string had a ring on each end and a spring scale, a device that can measure forces near one end. Okay, so it had a spring scale near one end. Block X having a mass mx was hooked onto the left ring. Block Y having a mass my was hooked onto the right ring. Block X was pulled down and held in place so that block Y was 1.5 meters above the platform. With all objects starting at rest, block X was released, and both F, the force on the string, and T, the time required for block Y to fall to the platform, were measured. All objects other than the 2 blocks had negligible mass, and the string was not stretchable. Table 1 shows the results with force in newtons and time in seconds. Okay. A dash indicates that block Y did not fall, right? Study 2, the acceleration A of block Y in each trial of study 1 was that calculated using the available data. So force is mass times acceleration. Table 2 shows those results. Okay. The speed of block Y can be obtained using the equation. Speed is acceleration into time. The speed of block Y at the time it struck the platform in trial 2 is correctly represented by which of the following expressions? Struck the platform in trial 2. Okay, so in trial 2, it struck the platform. Yeah, in trial 2, it was 3.27 and 0.96. So it's 3.27 into 0.96 B. Okay. Which of the following statements is consistent with the available information about the design or procedures of the studies? More trials were performed in study 2 than were performed in study 1. That's not correct. It's the same. In each trial, the mass of block X was less than or equal to the mass of block Y. The mass of block X was less than or equal to, yeah, that is correct. So second G is correct. The results of study 2 were unrelated to the results. That is not correct because this was acceleration, which was calculated using the available time data from here. So it is related. There was only one trial that involved testing blocks of equal mass. That's not correct. There were multiple trials, 0.2, 0.2, 0.4, 0.4. So the answer is G. Yeah. Suppose that in study 1, a trial had been performed in study 1 in which block Y was pulled down and then released when block X was 1.5 meters above the platform. Okay, in which block Y was pulled down and then released. Okay, further, suppose that in this trial, mx was 0.8 and my was 0.6. Right, so it's just like a different variation of the experiment, except that mx was 0.8 and my was 0.6, then the force on the string. So 0.6 and 0.8, that's the one we are looking at, right? And we are reversing this, right? Because we are going from so we are taking it the other way around. So 0.6, and so the force would be the same, right? It wouldn't matter. 6.72. So it would be about 7, right? C. Okay. Suppose that in step 3, block X had been pulled down and held in place so that block Y was 100 centimeters above the platform. Okay, so in step 3, this step, instead of 1.5 meters, it was 1 meter, that is 100 centimeters. Would the values of T recorded in study 1 more likely have been greater than or less than? Okay. So if it is 1 meter, then the time it takes is going to be less, right? Because it has to go down a distance of only 1 meter. So the time with the values of T, it would have been less because block Y would have fallen a shorter distance. So it's H. Right. Okay. Based on the results of the study for a given value of mx, as my was increased, which of the following variables also increased. So for a given value of mx, as my was increased, the force increased, right? The force increased, and as the force increased, the time decreased, and the acceleration also increased. So it was the force and the acceleration only, option A. Okay. Based on the description of study 1, was my a dependent variable or an independent variable? Okay, so my, I think, was a dependent variable, right? Because each time you changed my, you kind of changed, because mx was the same for trials 1 to 4 and then from trials 5 to 7. No, I don't think so. I think that was also an independent variable. Yeah, it was not dependent on it. It was an independent variable because in each trial, its value was intentionally set to one of several chosen values. Yeah, because you're choosing those values, right? So it's independent. Correct. Consider any trial in which the block masses were not equal. In this trial, once block X had been released, the gravitational potential energy of block Y immediately began to. So when it was released, gravitational potential energy is proportional to height. So obviously for block Y, the height declined, right? And its kinetic energy increased. So the gravitational immediately began to decrease because block Y began to lose height, right? So it's D. And its gravitational potential energy started converting to kinetic energy. Okay, that was 33. Let's go to how many have we have to do the conflicting viewpoints? That's the last one. Okay. So the demonstration is a science teacher poured 400 ml of water into a beaker and heated the beaker with a Bunsen burner. After a few minutes, bubbles began to form in the water and float to the surface. 4 students were asked to explain how the bubbles were formed and also to describe the composition of the bubbles. Okay. Student 1, the chemical formula of water is H2O. As H2O is heated, the chemical bonds between hydrogen and oxygen atoms break, leaving individual hydrogen and oxygen atoms. The hydrogen atoms dissolve in the remaining water, while the oxygen atoms combine to form oxygen molecules, O2. The breakdown of water and the formation of O2 can be summarized with the following balanced chemical equations. Because oxygen is a gas, it forms bubbles, and the bubbles contain oxygen only. Okay, student 2, student 1 is correct about how the chemical bonds in H2O break down and how oxygen molecules are formed. However, the hydrogen atoms do not dissolve in the remaining water, rather they combine to form hydrogen molecules. And because both oxygen and hydrogen are gases, bubbles are formed in the water and they consist of a mixture of oxygen and hydrogen. Okay. 3. The chemical bonds in water do not break when water is heated. Instead, water molecules form new chemical bonds called hydrogen bonds with other water molecules. As more and more hydrogen bonds form, a thin circular sheet of hydrogen bonded water molecules is formed. When this sheet comes in contact with the surface of the water, air pressure pushes down on the center of the sheet, causing it to bow in the middle and close up on itself, forming a spherical bubble. The bubbles contain air, a mixture of gases only. Okay. And that explains the bubbles, right? Okay. And as student 4, as the water is heated, chemical bonds are neither broken nor formed. Instead, the water molecules absorb the heat energy, and this energy is converted into kinetic energy. Once the kinetic energy reaches a certain threshold, the water begins to change from liquid to gaseous phase, forming bubbles that contain water vapor only. Okay, so those are the 4 explanations. Okay. Based on the description of the demonstration, were the bubbles that formed more dense than the surrounding water or less dense than the surrounding water? So float to the surface, right? So they have to be less dense because they float to the surface, J. Okay. During the demonstration, bubbles were observed to form well below the water surface. This information directly contradicts the explanation given by student 3, right? Because according to student 3, the bubbles can only be formed at the surface of water, because that's where the sheet the circular sheet he's talking about comes in contact with air, right? So if the bubbles are being formed even below the surface, then it goes against the third student's explanation. So that's just C. Which student stated or implied that the bubbles contain gas molecules? So definitely 1 and 2, 3 as well, and water vapor. So actually all four say that it contains gas molecules. According to students 1, 2, and 3, the process of bubble formation involves which of the following changes? Chemical bonds are formed. Yeah, chemical bonds are formed, right? They form new chemical bonds. Yeah, so there is no breaking in the case of the third one. It's only, so it's A. Suppose that after the students gave their responses, the teacher filled a balloon with a mixture of hydrogen and oxygen. Further, suppose that she held a lit candle to the balloon and then the balloon exploded. Based on this information, which of student 2 and student 4, if either, would be more likely to claim that an explosion would have occurred during the original demonstration if the teacher had held a lit candle above the surface of the water being heated? An explosion would have occurred because it expanded, the gas expanded, right? Uh, no, this expanded and therefore it exploded. So it was because there was a no, there's no sense of the balloon explodes because the air inside it stretches it, right? But there's no sense of any stretching material in student 2 and student 4 accounts. I mean, can we say that hydrogen might explode, but that's not a reason for the balloon exploding, right? So I'll go with neither student 2 nor student 4. Yeah, okay. Which student's explanation is the most scientifically accurate? I think it seems to be D, right? The student is the most, like, he just gives it in terms of, water being converted to vapor form and the vapor is released as bubbles. So there's no chemical bonds discussion here. It's just a physical process. So that's just D. Which of the following balanced chemical equations best summarizes student 2's explanation? So that will just be 2H2O leading to 2H2 plus O2 because that's what he's saying. Yeah, so that's just 2H2O breaking down into 2H2 plus O2. So that's just F. Okay, that was the science section. Let's grade it. BGCJA, BGCJA, JBGAH, JBGAH, CJAHB, CJAHB, JAJCF, JAJC. Oh, 20 is F. Okay. So 1 second. 20 is F. Okay. And the right answer is F. Okay. 20 is F. Then 21 BFDHA, BFDHA, JBGCJ, JBGCJ, 30 is J. Okay. 30 is J. Okay, 31 AHDJC, AHDJC, JAFDF, JAFDF. Okay. So we got 3 wrong in this. Let's look at what happened here. Okay, so we'll go to question 20 first. 20th is, this is 20th. Which of the following best summarizes the procedure of experiment 3? And my answer was G. They repeatedly adjusted the latitude at which until the resulting MOD for each disk was slightly larger than 2 centimeters. Oh, right, correct, yeah. Once the latitude was fixed, they adjusted the speed, right? Yeah, they didn't adjust the latitude once it was fixed, because once the latitude was fixed, they kind of adjusted speeds to figure out where the point where they would just kind of deflect each other, right? So that's how they found the minimum speed. So that's correct. That's 20th. What about 30th? 30th. Block X had been pulled down and held in place 100 centimeters. So 30 is J less because, yeah, that's what I meant to choose, no? It would have fallen a shorter distance. Didn't I say that when I was explaining that it would fall a shorter distance? I think I may have, this was a silly error. I meant to say J. Okay, and 38. 38 is interesting. Yeah, student 2 would say that there was, I think the reason student 2 would say that there would be an explosion is because I think hydrogen might catch fire because there's a creation of hydrogen, but I was not comfortable choosing that because the reason the balloon explodes is not because of the contents inside the balloon catching fire, right? It explodes because the gas inside it expands. So yeah, but if you consider it as the fact that hydrogen might catch fire, then, or maybe even the fact that oxygen would aid in the combustion. Right, so 38 was a genuine mistake, but I think, and 20 was just also a genuine mistake, but silly. I could have gotten that right, and 30 was a really silly mistake, right? Okay, so that was the science section of the December 2020 ACT. That brings us to the end of the entire paper. We have now finished all sections of the paper. I'm going to upload all of them into a playlist that you can check out. Hope you found this useful. If you did, please hit the like button and consider sharing and subscribing to the channel. I'll see you guys soon in a new video. Take care. Bye-bye.